Hi guys, this is AS Chemistry, Analytical Chemistry, and we are doing mass spectrometry. Question 1. The three peaks of the highest mass in the mass spectrum of organic compound L corresponds to masses of 142, 143, and 144. The ratio of the heights of M is to M plus 1 peaks is 43.3 is to 3.35, and the ratio of the heights of M and M plus 2 peaks is 43.3 is to 14.1. Use the data to calculate the number of carbon atoms present in L. So the number of carbon atoms is given by the formula 100 upon 1.1 into m plus 1 peak upon m peak height. So this would be 100 upon 1.1 multiplied by 3.35 upon 43.3, giving us a value of 7.03, which is rounded to 7, as the number of carbon atoms will be in whole number. So 7 carbon atoms are present in this compound. Explain what element is indicated by M plus 2 peak. So if we divide 43.3 by 14.1, we get a value of 3. So basically, M is to M plus 1, or rather m plus 2 is in the ratio of 3 is to 1, and this ratio corresponds to the presence of chlorine isotopes. Therefore, chlorine is present in the compound. Since chlorine has two isotopes, Cl35 and Cl37, in the ratio 3 is to 1, if we are getting a ratio of 3 is to 1, that means chlorine has to be present in our compound. The molecular formula C3H6 represents the compound propene and cyclopropane. So propene and cyclopropane are given. Suggest one difference in the fragmentation patterns of the mass spectra of these compounds. So in propene, the bond that would break would be the CH3CH bond, and in cyclopropane, any one bond would break, which would result in opening up of the chain, and fragmentation will not be there. So we will end up with fewer fragments in cyclopropane than in propene. So suggest one difference: fewer fragments in cyclopropane as compared to propene. And another thing that can be given as a difference is propene would have a fragment peak at m/e value of 15, corresponding to the CH3 group. Question 2. Compound P is an alcohol that can be converted into compound Q in the following reaction sequence. P gives a compound CxH6O, and then it gives Q. Spectral analysis of P and Q were carried out. The mass spectrum of P shows an M is to M plus 1 ratio of 4.5 is to 0.15. Calculate the number of carbon atoms in P. So number of carbon atoms is given by 100 upon 1.1 into M plus 1 height upon height of M peak, which is equal to 100 upon 1.1 into 0.15 upon 4.5. This gives us a value of 3.03, which is rounded to 3, as the number of carbon atoms have to be in whole number. So 3 carbon atoms are present in compound P. Question 3. The mass spectrum of a compound G contains M and M plus 1 peaks in the ratio of their heights of 74 is to 2.5. Use this data to calculate the number of carbon atoms present in G and show your working. So number of carbon atoms is equal to 100 upon 1.1 into M plus 1 upon M. giving us a value of 100 upon 1.1 into 2.5 upon 74. This gives us a value of 3.1, which will be rounded to 3 as the number of carbon atoms are in whole numbers. So this is a compound which contains 3 carbon atoms. Question 4. Natural phosphorus consists of one isotope P31. Chlorine exists naturally as two isotopes Cl35 and Cl37 in the relative abundance ratio of 3:1. The mass spectrum of PCl3 contains several peaks corresponding to a number of molecular fragments. Suggest the isotopic composition of the fragments with the following mass numbers. So, in all of these, we would have phosphorus with a mass of 31 present. So, 101 minus 31 gives us 70. So we would have two chlorine isotopes, each having a mass of Cl35 present in it. Next, if we subtract 31 from 103, we end up with 72. So we would have a chlorine atom with a mass of 35 and the other isotope with a mass of 37 present on it. This would give us a total of 72 mass difference. And 105 minus 31 gives us 74, which means both the chlorine isotopes present are Cl37 in the molecular fragment. Question 5. T is a saturated alcohol. It was analyzed by mass spectroscopy. In the mass spectrum, the molecular ion peak M was at Me value of 74, which is its Mr value, and the ratio of the heights of M and M plus 1 peaks was 20.4 is to 0.9. Use the ratio of the heights of the M and M plus 1 peaks to calculate the number of carbon atoms in the molecule of T. So N would be equal to 100 upon 1.1 into height of M plus 1 upon height of M. So this gives us 100 upon 1.1 multiplied by 0.9 upon 20.4. This gives us a value that will be rounded to 4. Therefore, the compound T here contains 4 carbon atoms. And T is an alcohol, so it would contain an oxygen atom as well. So 4 carbon atoms have a total mass of 48. A single oxygen atom has a mass of 16. And if we add 48 and 16, so we end up with 64. So out of the MR, which is 74, we subtract 64 and we end up with 10 atoms of hydrogen. Therefore, the molecular formula of this compound would be C4H10 and O. And this is because it is a saturated alcohol and all the carbon atoms would form single bonds with hydrogen atoms and one single bond with oxygen, which forms a single bond with hydrogen for the OH group. Question 6. Chlorine exists naturally as a mixture of two isotopes Cl35 and Cl37 in the abundance 3:1. The mass spectrum of chlorine consists of 5 peaks. Suggest the mass numbers of these 5 peaks and the identities of the species responsible. So, if we have a sample of chlorine, so we would have a chlorine atom and a chlorine molecule present. So, mass number of formula of species. So, one of the formula could be of the isotope Cl35 having a mass number of 35, and we can have a Cl37 with a mass number of 37. And next we can have a Cl2 in which both chlorine isotopes are Cl35. So a grand total mass of 70 would be present in this molecule. Then we can have another Cl2 molecule, one of the chlorine isotopes being Cl35 and other being Cl37. So this would give us a mass of 72, and we can have yet another molecule of chlorine with both isotopes present as Cl37 isotopes with the grand total MR value of 74. Therefore, we will have five peaks in the mass spectrum of chlorine having masses of 35, 37, 70, 72, and 74. Question 7. The mass spectrum of the element magnesium is shown. So magnesium has three isotopes with the MR or rather AR value of 24. The relative abundance would be 10, 20, 30, 40, 50, 60, 70, and just below 80. So let's put it at 79. For the mass of 25, the abundance would be 10. 79 plus 10 is 89. 100 minus 89 would give us 11, which is seen as the mass of 26 is just above the relative abundance value of 10, so 11. So these are the values of relative abundances as taken from the mass spectrum provided. Use your values in 1 to calculate the relative atomic mass of magnesium to two decimal places. So we need to calculate the AR. So AR would be equal to 79 upon 100 into 24 plus 10 upon 100 into 25 plus 11 upon 100 into 26, giving us an AR value of 24.34. Question 8. A sample of lead consists of the following isotopes in the percentage abundances stated. Use this data to calculate the relative atomic mass of the sample of lead to two decimal places. Okay, so in order to calculate the AR, we have 1.9 upon 100 into 204 plus 24.8 upon 100 into 206 plus 21.4 upon 100 into 207 plus 51.9 upon 100 into 208. Adding all these values together gives us an AR value for lead to be equal to 207.21. Question 9. When an isomer of P is heated with concentrated H2SO4, it forms a new compound Q. This new compound Q reacts with bromine to give a dibromide R. A mass spectrum was obtained of R. The ratio of the heights of M and M plus 1 peaks was 9.3 is to 0.5. Show that there are 5 carbon atoms present in one molecule of R. So, number of carbon atoms is given by the formula 100 upon 1.1 into M plus 1 height upon the height of M, which will be equal to 100 upon 1.1 multiplied by 0.5 upon 9.3. This gives us a value of 4.89, which will be rounded up to 5 because the number of carbon atoms will be in whole numbers. Therefore, 5 carbon atoms are present in the molecule R. Question 10. The mass spectrum of silicon is shown. Relative intensity is given. Calculate the AR of silicon. Give your answer to two decimal places. So, if we have to calculate the relative intensity, we need to find the denominator, which would be 0.922 added to 0.047 added to 0.031. So 7 plus 1, 8, 9 and 10. 0, 1 carries over, 3 and 4, 7, 8 and 10. 1 carries over, 9 plus 1, 10, 1. Actually 0 and 1 carries over, so 1. So the denominator value is 1. So we don't need a denominator in this calculation. So in order to calculate the AR, now what we would do is we would have 0.922 multiplied by 28 plus 0.047 into 29 plus 0.031 into 30. When we add these values together, we get an AR value of 28.11 for silicon. Question 11. The mass spectrum of a halogenoalkane containing one chlorine atom or bromine atom will show an additional peak at M plus 2. State the isotopes of chlorine and bromine responsible for M plus 2. So for chlorine, it would be the Cl37 isotope, and for bromine, it would be the Br81 isotope. The mass spectrum of bromochloromethane, CH2BrCl, so it has one of each halogen, has a molecular ion peak M at an Me value of 128. It also has M plus 2 and M plus 4 peaks. Suggest the identity of the molecular ions that give rise to these peaks. So the M peak would be CH2, Cl35, and Br79. So this would give the M peak. The M plus 2 peak would be if either the chlorine or the bromine isotope has been replaced by the other isotopes. So we can have CH2, Cl35, Br81, or we could have CH2, Cl37, and Br79 for the M plus 2 peak. And for M plus 4, both the isotopes Cl35 and Br79 will be replaced by Cl37 and Br81, giving rise to the M plus 4 peak.